Hello guys, I welcome you to the second lecture from chapter 1 in grade 11 chemistry book. We are talking about stoichiometry. In the first lecture, we discussed what stoichiometry means and what is stoichiometric calculation. Today, we are going to talk about a couple of concepts, that is mole and Avogadro's number. So let's begin. First of all, we're going to talk about the mole. So what is a mole? Mole is the atomic number of an atom, the formula mass of a formula unit, and the molecular mass of a compound expressed in grams. Simply, if you express the atomic masses of elements in grams or the molecular masses of molecules in grams, that makes up a mole. For example, you already know that the atomic mass of nitrogen is equal to 14. If you express this value in grams, this is equal to 1 mole of nitrogen atoms. But you know that nitrogen usually exists in the form of a molecule. So N2 is equal to 28, and if you add a unit, that is gram, so it means that 28 grams of nitrogen molecules is equal to 1 mole of nitrogen molecule. Similarly, the atomic mass of oxygen is equal to 16. So if you express this in grams, this is equal to 1 mole of oxygen atoms. But again, oxygen exists as O2. So O2 is equal to 32, and when you express this in grams, this is equal to 1 mole of oxygen molecules. Similarly, you can have another molecule like, for example, water. The molecular mass of water is equal to 18, and when you express this in grams, this is equal to 1 mole of water molecules. So 1 mole of water is equal to 18 grams. Similarly, if you have a formula unit like sodium chloride, sodium chloride is the formula unit of this ionic molecule. So this is equal to 58.5, and if you express this in grams, it means that 1 mole of sodium chloride formula unit is equal to 58.5 grams. You can also apply the concept to ions. For example, sodium ions in sodium chloride. Now, the ionic mass is equal to 23 for sodium, and when you express this in grams, it means that 1 mole of sodium ions is equal to 23 grams. Or you can say that 23 grams of sodium ions is equal to 1 mole of sodium ions. So again, let me revise it. 1 mole is equal to the atomic mass of an element expressed in grams, the molecular mass of a molecule expressed in grams, or the formula mass of a formula unit expressed in grams. Now let's talk about another concept, that is Avogadro's number. Avogadro's number is a number that expresses or that shows the number of atoms or molecules or ions in 1 mole of a substance. So as we just saw examples of atoms and molecules and ions, if you take 1 mole of any of these substances, it will have a particular number of atoms, ions, or molecules, and that number is equal to 6.023 into 10 raised to power 23. So it means that 1 mole of oxygen is equal to 6.023 into 10 raised to power 23 oxygen atoms, or 1 mole of O2 is equal to 6.023 into 10 raised to power 23 O2 molecules, or 1 mole of water is equal to same number of water molecules, or 1 mole of sodium ions is equal to same number of sodium ions. So Avogadro's number is the number of atoms, ions, or molecules present in 1 mole of a particular substance. The numerical value is equal to 6.023 into 10 to the power 23. So you can apply to atoms, ions, or molecules. And if you apply the same concept to, for example, gases like oxygen or nitrogen, you can say that 1 mole of any gas will have this much molecules and it will occupy a volume that is equal to 24.414 decimeter cube at STP, that is standard temperature and pressure. Let's apply this concept to a chemical reaction. So for example, you have a methane molecule reacting with oxygen to produce carbon dioxide and water. In the previous lecture, I told you that you must have a completely balanced chemical equation. So you can balance it by multiplying O2 with 2 and then water with 2. So you will have equal number of carbons, hydrogens, and oxygens on both sides of the chemical reaction. Now let's apply the concept of Avogadro's number. This chemical equation tells us that 1 mole of methane reacts with 2 moles of O2 to produce 1 mole of carbon dioxide and 2 moles of water. If you want to express this chemical equation in terms of the number of molecules, it will mean that 6.023 into 10 to the power 23 molecules of methane react with 2 into 6.023 into 10 to the power 23 molecules of oxygen to produce 6.023 into 10 to the power 23 molecules of carbon dioxide and 2 into 6.023 into 10 to the power 23 molecules of water. Now this is how you can convert moles or molar ratios into number of atoms, ions, or molecules. So 1 mole of oxygen is equal to 6.023 in 10 to the power 23 atoms. 1 mole of O2 is equal to 6.023 into 10 to the power 23 molecules of oxygen. 2 moles of O2 will mean that you multiply this Avogadro's number by 2 and so on. So today we discussed two concepts, moles and Avogadro's number, and then we saw how you can convert moles into number of atoms, ions, or molecules, or you can convert even the number of atoms, ions, or molecules into the number of moles. So if you are given a particular number of atoms, ions, or molecules of a substance, you can calculate the number of moles from that number and you can then convert it into grams as well. So thank you so much for today. And in the next lecture, we will talk about how to apply the number of moles or molar ratios in stoichiometric calculations in chemical reactions. So thank you so much for today and see you tomorrow with a new concept.